Hello guys, welcome to this video. Let's start with the solution of LTC AIIMS Chemistry Weekend Test number 17. So question number 51, that is question 1 of chemistry section is, this is a given data and we have to determine at what temperature the following reaction is spontaneous. And you guys know that delta G, which is equal to delta H minus T delta S, it should be negative for the reaction to be spontaneous. That means T delta S should be greater than delta H, or temperature should be greater than delta H divided by delta S. So you find out the enthalpy change for this reaction, products minus reactants, and likewise the entropy change, products minus reactants, and then substitute values in this formula, right? So temperature will come out to be 963 point something, so approximately 964 Kelvin. So that is the correct answer. Entropy change in a reversible process is zero, right? So of course in a reversible adiabatic process it will be zero. Which of the following halogens has metallic character? Iodine. Iodine has metallic luster. The high reactivity of fluorine is mainly because of the low bond dissociation energy of fluorine-fluorine bond, right guys? Because of the small size, the bond length is low, and the lone pair lone repulsion in fluorine are very high. So as a result, bond breaks easily and it reacts. Electron affinity values are given, then x, y, and z respectively are of course this, because in case of fluorine the small size leads to large electron repulsions, and as a result it does not have very high electron affinity value. In fact, chlorine does. So chlorine has the highest value, followed by fluorine, then bromine, and then iodine. So this is the correct answer. In this, the correct match is this one. The melting point A matches with fifth, right? Of course, down the group the molecular size increases, mass increases, so the magnitude of dispersion forces increases, so melting and boiling points increase, right? Now electron affinity, I've just told you the order. Chlorine has highest, followed by fluorine, bromine, and iodine. As regards bond dissociation energy, this is the order, something you should learn. First is chlorine, then bromine, then fluorine, and then iodine. Okay, right? So this is the order of bond dissociation energy. So this is the correct answer. The solubility of I2 in Ki solution is more than its solubility in pure water, because iodine reacts with the iodide ion to form triiodide ion, I3 minus. So this makes it ionic compound, so it becomes soluble, right? So I2 forms soluble complex Ki3 with Ki. That is the correct answer. This is the oxidizing strength. Memorize this, right? Fluorine atom has a less negative electron affinity than chlorine atom. Yes, because of electron repulsions. The additional electron is repelled more effectively by 3p electron in chlorine atom than by 2p electron. This is incorrect because of the smaller size. Electron repulsions are more significant in fluorine, right? So statement 1 is correct, but 2 is not. So this is the correct answer. Halogen with least density is fluorine, because down the group mass increases, and the increase in mass outweighs the increase in size, so overall density increases. B, P, A, and Q are elements belonging to 17th group of modern periodic table. The correct trend of atomic radius is this. The element Q in the sequence is of course iodine, because down the group atomic radius increases. The element P in the sequence is of course iodine, because iodine is the weakest oxidizing agent in this, right? And fluorine is the strongest oxidizing agent in group 17 elements. The following structure is uracil. Remember this structure. X is sugar moiety present in DNA, which is 2-deoxyribose. Alright guys, so this is ribose. 2-deoxyribose means this oxygen is gone, right? And in the free state we of course have 3 hydroxyl groups, right? So this is the correct answer. Incorrect statements are B and C. Deoxyribose is functional isomer of ribose. No, because there is a difference of oxygen, so they're not isomers at all. Insulin is an amino acid hormone. No, insulin is a peptide hormone, right? It contains polypeptide chains. So B and C are incorrect. Condensation of alpha amino acids lead to the formation of polypeptides and proteins. Number of peptide bonds in a tetrapeptide. Okay, so dipeptide contains one peptide bond between 2 different amino acids. So tetrapeptides means there are 3 peptide linkages, right, between 4 different amino acids. So that is the correct answer. Valine is a neutral amino acid. Yes, it has an isopropyl group at the alpha position, right? So this is like CH2, CH, and then CH CH3 twice, right? In the structure of valine, there is one NH2 and one CH group. Yes, both statements are correct. Maximum number of tripeptides which can be obtained from the 20 naturally. So we have to form tripeptide. There are three positions for peptide for amino acids, and there are 20. So of course it's simple mathematics. So the maximum number of possibilities will be 20 multiplied by 20 multiplied by 20. So the correct answer would be 8,000. The relative configuration to find out that the most oxidized carbon, which is CHO, should be on the top. So what I will do, I'll fix this CH2H here and rotate them, right? So it would be CH2OH, CHO will go at the top, OH will come on the left, H will come on the right. So of course it is L because hydrogen is on the right hand side, OH is on the left, right? So this is L configuration. What is the relation between the two hemiacetal form? The most appropriate answer is anomers because they have different configuration at the first chiral carbon. The following structure represent beta D fructofuranose, right? If this OH group would have been here, then it would have been alpha D fructofuranose, right? Regarding cellulose, the correct statements are A, B, C, and D. It involves C1, C2 glycosidic linkage. No other statements are correct. Is that clear? Which of the following oxidation reactions can be carried out with chromic acid and aqueous stonium? This is the correct answer, right? Because we are oxidizing secondary alcohol to ketone. Is that clear? Chromic acid is a strong oxidizing agent. It will not oxidize alcohol to aldehyde, but to carboxylic acid, right? So this is the correct answer. In this case, CH3CN, this is a nucleophilic addition of Grignard reagent like this, okay, and then upon hydrolysis this converts into keto group, right? So acetone is the final product. The products here benzene, here you have C2H5 COCl anhydrous AlCl3. So this is Friedel-Crafts acylation reaction. So C double bond O and then CH2 CH3. And if you use diphenyl cadmium with CH3 COCl, then you get what? Benzene and then C double bond O and then CH3. So of course they are homologs because they are differing from each other by a CH2 unit, right? In order to prepare acetone from acetyl chloride in one step, which of the following agents will be dimethyl cadmium, of course, because if you use dimethyl cadmium with acetyl chloride, so there is a nucleophilic reaction, right? Methyl attacks and chloride leaves, resulting in the formation of acetone. Okay, so this is the correct answer. Boiling points of carbonyl compounds are greater than corresponding ethers and hydrocarbons. Yes, because dipole-dipole interactions are stronger in aldehydes and ketones. And yes, that is the statement. So this is the correct answer. Correct statements are A, B, and C here. Higher aldehydes are sweet smelling, for example, cinnamaldehyde, vanillin, etc. N-pentane, diethyl ether, butanal, and N-butyl alcohols. The correct increasing order of boiling point is this. This is an exception, remember, right? Diethyl ether, it has a lower boiling point, although it has a dipole-dipole interaction, which are absent in N-pentane, but still N-pentane has slightly higher boiling point in that. Which one is most reactive towards nucleophilic addition reaction? Of course, this, because an electron withdrawing group will increase the delta positive charge. That is, it will increase the electrophilicity of the carbonyl carbon. So this will be most reactive. The decreasing order of reactive towards HCN. So this would be the third option, because aldehydes are more reactive than ketones because they only have one electron donating alkyl group. So these two compounds are more reactive than this, and acetaldehyde is smaller, acetone later, and ditert butyl ketone is very bulky, whereas methyl tert butyl ketone is little less bulky than the compound C. So this is the correct order. Give decreasing order of the following towards nucleophilic addition reaction. The correct answer is third, because the presence of chlorine will slightly increase the reactivity because of the minus I effect of it. Okay. Okay, next question. Which of the following is a crystalline compound with CH3CHO? Bisulfite addition products are crystalline solids. So this would be the correct answer. The equilibrium lies towards right, because the reaction of aldehydes is favorable with bisulfite but not for ketone because of steric hindrance. So this is the correct answer. The major organic product in this reaction, this is an intramolecular Cannizzaro reaction. Both carbonyl groups do not have alpha hydrogens, so this would undergo oxidation, this would undergo reduction, right? So this would be the product. The thermodynamic property whose absolute value can be determined, entropy, and how, using third law of thermodynamics. Which of the following reactions correct relation at this? So remember guys, the relation is delta G naught is minus RT ln Kc. So of course this is a correct answer. You can find out, first you find out delta H, which is delta U plus delta NGRT, right? Delta U is given to be 2.1 kilocalorie. Delta Ng is gaseous products minus reactant, so which is 2. The value of R in calories 2, temperature is 300. Let us convert it to kilocalorie by dividing it by 1000. So this is 2.1 and it is 12, so 1.2. So this is 3.3, right? Finally, find out delta G using this relation, delta H minus T delta S. So you'll find out the answer to be minus 2.70. Okay. It's simple. Gibbs energy of the reaction is products minus reactants. So for the product, it is Cu2 plus, which is 66, minus reactant, which is Cu plus, and it is 50. So 66 minus 50 is plus 60. Delta G is delta H minus T delta S, and if delta H is negative, this is favorable, but delta S is negative, which is unfavorable. So this overall term would be positive. So this term should not dominate, and as a result, temperature should be low in order for the Gibbs energy to be negative, that is for the reaction to be spontaneous. So the given reaction would be spontaneous below a certain temperature, right? Delta G is X, delta G is Y. Reaction R1 is non-spontaneous, so definitely X is positive. But along with R2, it becomes a spontaneous. So you know that when we add reactions, Gibbs energy also gets added up. So Y should be negative and negative enough to make the overall energy change negative. So this is of course true. X is positive, Y is negative, and overall Y should have higher magnitude than X, right? For a system at 300 Kelvin, change in enthalpy is 150, change in entropy, Gibbs energy. You apply this relation, delta H minus T delta S, you will find out that, okay? Delta H is given to be how much? 150 kilojoule, temperature is 300, delta S is 400. Don't forget to divide it by 1000 to convert it into kilocalories, so we'll find out the correct answer, plus 30. Which of the following situation will need high temperature for a reaction to become spontaneous? Again, the same logic. If you want the reaction to be spontaneous at high temperature, then this term should dominate. In that case, delta H should be positive, delta S should be positive, right? So this would be delta H positive would be unfavorable, delta S positive would be favorable, but then temperature should be sufficiently high. So this is the correct answer. In the Cannizzaro reaction, the rate determining step is the transfer of the hydride from one molecule to the other, right? In sodium formate, both the carbon have same bond length. Yes, this is correct, because the resonance structures are equivalent, right? Equal bond length is due to the phenomenon of resonance. Yes, that is correct. CH3CH2H, it is PCC, so oxidation happens, you get acetaldehyde, then you undergo reduction again, you get again ethanol, and then John's reagent on oxidation gives ethanoic acid. And remember, carboxylic acids are isomeric with esters, so this is the correct answer. It cannot be tertiary alkyl group because it doesn't have any hydrogen to initiate oxidation, otherwise all these groups can be oxidized to carboxylic acid, the side chain oxidation. Correct order of increasing boiling point, this is the correct answer. Carboxylic acid has the most powerful, like the strongest hydrogen bonding, followed by alcohol, and then aldehyde do not have hydrogen bonding. It has dipole-dipole interactions which are weaker than hydrogen bonding. So this is the correct answer. Carboxylic acids are more acidic than carbonic acid. Of course, this is very simple. You take away H plus from carboxylic acid, and then HCO3 minus H plus, it is H2CO3, which is unstable, so it gives you H2 and CO2. So basically the carbon in carbon dioxide comes from bicarbonate, not from carboxylic acid. So this is the correct answer. Correct strength of acids of these carboxylic acid is the second option is the correct answer. NO2 is an electron withdrawing group, it increases acidity. OCH3 and CH3, these are electron donating, right? Because at para position, minus I effect is negligible, but plus R effect will work. So OCH3 will act rather as an electron donating group here, right? And so most acidic is first, followed by fourth, and then third, and then second, because resonance is stronger than hyperconjugation. So this is the correct answer. Thank you guys.